Curt mistakenly multiplied a number by 10 when he should have divided the number by 10. The answer he found was 33.66 more than the answer he should have found. Find the original number. A MOEMS problem. Now we're only given one number. Of course, that eliminates finding a pattern in this problem. I mean, if you want to find a pattern in math, you need a whole lot of numbers. We only have one number. One is not a whole lot of numbers. Okay, you could count the tens, but that doesn't help us a lot. So we could try trial and error, or we could try just making an equation, which would also be pretty efficient. But we don't want to do trial and error, because what trial and error means is basically guessing and checking. You guess the number, multiply by 10, divide by 10. You find the difference and hope the difference is 33.66. I mean, we got a decimal here. There's a whole, you could get 33.67 and still not get the right answer. That's not 33. Integer would be a little less work to do, but we don't like this, so skip trial and error. You're going to make an equation. That's much smarter. So, let me see. First, we assign a variable. That's the original number, which is a pretty good variable. Assign that for, let's see, A. And Curt mistakenly multiplied a number by 10. That means what Curt did was he multiplied A by 10 and got 10A. Now equation, we need an equal sign, so put that in. Now he should have divided by 10. That means if he divided by 10, he chose A divided by 10 instead. Well, what we're told is 10A is 33.66 more than A divided by 10, because, well, they told us that. So if we take 10 divided by A divided by 10, and we add on that 33.66, we get 10A. And of course, you also just could have done it the other way around. You could have seen if this 10A is 33.66 more than A divided by 10, well, if we subtract off that extra 33.66, you do get A divided by 10. It's basically the same thing either way you do it. So now all you have to do is solve this equation for A. Now first we can get rid of that 10. I'll deal with the decimal later. So multiplying by 10 on both sides gives us 100. A over here. A plus, remember, you gotta multiply that by 10 as well, making 336.6. And subtracting A, get 99A. Oh boy, I wish that 100 was a 101. That'll make 100A, but that's okay. Well, here we got, let's see, 336.6. Now we just have to divide by 99, and we get A is this divided by 99. I'll use long division for that. After we get rid of those annoying decimals, break that as a fraction, we can multiply top and bottom of this fraction by 10. You get, oh boy, 3,366. And let's see, 990 here. Now, let's see, long division. Have, oh boy, these two large numbers. Well, if we multiply this by 4, we get 3,600 something. That's way too large, since, 40 times 900 is already 3,600. So we think 3 is right, and if we write that in, 3 times 999, 3 times 0 is 0, 3 times 90 is 27. 3 times 9 is 27. 3 times 9 is another 27. That's 29. Get that out of there so we don't mess up. Now we just have to subtract these. And 6. Here's a little borrow. 9. 3, and that's there. And, okay, we need a decimal point to drop in. I guess a couple, maybe. 0.0. Drop that down. And this goes into that. Well, we know we can go in 3 times, but 4 times, that's 3,600 something again. And that's pretty close to 3,600. Let's try 4. Well, that gives us 4 times 0, 0. 4 times 9 is 36. 4 times 9 is another 36. And adding in the 3, we get these two numbers. Subtract these, we get a whole bunch of big fat zeros. Yeah, I forgot the decimal point there. And since this is that divided by that, this is 3.4 is our answer.